Just like, excuse me, God. Just like the first derivative, the second derivative can tell us a lot of stuff. One of them, if the second derivative is greater than 0, it says the function is concave upward. What does that mean? Looks like this, opening upward. If the second derivative is less than 0, the function is concave downward. Looks like this. And if the second derivative is equal to 0, that's your possible inflection point. What's inflection point? That's what we know as change of concavity. This pen is dying too. So that's an inflection point. That's this one. See how concave upward till it hits that point, then it's concave down. Or it could be like this. Those are known as inflection points, change of concavity. Concave down, it hits the point, it goes to concave upward. So let's take an example. And actually, if you put the first derivative and the second derivative, you'll have a better picture. If you put the two of them. Because if you look at this piece of concave upward, see this one? So if you break it down to two parts, this is one part, this is the second one. What's the story with this part? Is the function increasing or decreasing on this end? It's decreasing here. And is it concave up or down? Concave downward, upward, I mean. It's opening upward, right? Because notice that's part of the half the circle. That's upward. This one is increasing and still concave upward. Let's take the concave down. It looks like this. That's concave downward. Let's slice it in half and look at it as two pieces. This is what? Increasing. Concave which way? Downward. And this one what? Decreasing. Concave downward. Maybe I'll go back just to speed up the process, and I'll take one of the early examples that we did. Let's take this problem here. I know we just did that one. I'll go through the whole problem. F of x is x squared minus 4 to the power of 2/3. We just did that one. We found the derivative of that. Ooh, maybe I shouldn't start with that. That's not a pretty one. Let me start with a different one. Instead of 2/3, let's change the power, because that's ugly to start with. Let's say it's squared. And I say, what's the derivative? I want to go the whole thing. Do the first derivative, the second derivative, everything. If I want to take the derivative of this, guess what? I'm going to be smart. I'm going to FOIL this one. I'm not going to use the extended power rule. If you open that, that's what? X to the 4th minus 8x squared plus the 16 if you FOIL it. Taking the derivative is much quicker now. What's the derivative of that? 4x to the third minus what? 8 times 2, 16x. I just said I'm going to do the first derivative and the second derivative. I'm going to do all of it. So let's take the first derivative, set it equal to 0. To find the critical values. Factor 4x out. What's left? X squared minus what? 4? Set it equal to 0. Each factor. When I say set it equal to 0, that means set each factor equal to 0. And solve it. So we have critical values are the -2, the 0, the 2. I can tell you I did not plan for this problem to fall like this, be beautiful, but it did work out nicely, just luck. I'm going to do the whole thing. I'm not going to make my table as big as the book because the book makes it really big. When I put the two on top of each other, I'll need the sheet like a huge sheet. So I'm going to make one sheet on the back, keep referring to that, and I'm going to put these values on it. So this is going to have a summary of everything. So the first layer is, I'll just make it wide enough so to write everything in it. That's the first derivative. And the second one is the second derivative. So this is for f prime of x. And this is for f double prime of x. In a few minutes we'll look at the double prime. So this line is the negative infinity. That line is the infinity. So we're going to break this one into what? -2. There's a line at -2. There's one at 0. There's one at 2. We're talking about the first derivative. So the -2 only goes to the first derivative. The 0 and the 2, right? And let me find the y value while I'm at it. When x is -2, what's -2 squared? 4, right? 4 minus 4, 0, square it, 0. When x is 2, is going to be 0. What about when x is 0? -4 squared, that's 16. And let's check the first derivative to see if it's positive or negative. For test point, I'm going to pick a value less than -2. I'm going to choose what? Maybe -3. Then a value between -2 and 0. I'm going to choose what? -1. A value between 0 and 2. I'm going to choose what? Maybe 1. And more than 2, how about a 4? Let me test them into the derivative. This is the derivative here. Can you see it? So what is the derivative at -3? -3 cubed is -27. -27 times 4, is that -108? Yep. And this would be plus 48. So the result is negative. I don't care what the value is. I just want to know negative or positive. That's a negative. I just put minus signs. That tells me it's decreasing. I'm going to put a lot of minus signs. You know it's negative. Let's take the derivative at -1. That's -4 plus 16. Positive or negative? Positive. That's increasing. That's the min point. I already found it. Let's take the derivative at 1. That's 4 minus 16. That's negative.
Wouldn't you not have to, because of Rolle's theorem, because those two both equal 0, right? And then,
You could.
yeah.
Yep.
Okay.
Very good. You could. And what about after the 2? It's going to be a positive. 256 minus the 64, which is way positive, and that's increasing. That's a min. So I can tell you, first derivative is done. I can tell you where the function is increasing, where the function is decreasing, where the min, where the max, everything. Now I need the second derivative to finish the bottom half. This is what we're going to be doing next class, to graph them. We're going to put everything together. So I'm kind of cheating. I'm bringing really the next section into it already. Because our book doesn't care about it. Just want to know it's increasing, decreasing right now. Concave up, concave down. I'm showing you how we're going to graph them with just knowing this information. So let me take the second derivative. And that's the derivative of the first derivative. 4 times 3, which is what? 12x squared, I think. Minus 16. Set it equal to 0. 12x squared equals 16. X squared equals what? 16 over 12, which is 4 over 3. X equals plus or minus 2 over the square root of 3. So we have two values for the second derivative. Curiosity what these numbers are. What is the square root of 3? 1.7? So 2 divided by 1.732, I think. Approximately plus or minus 1.15. So when you put them down there, the minus 1.15 is going to be somewhere here. And the plus 1.15 is right there. That's for the second derivative. So the values for them, negative 2 over the square root of 3, 2 over the square root of 3. And maybe I can find the y value while I'm at it. The y value, go to the function, square that. 4 over 3 minus the 4. What's 4 when divided by 3? That's 12 over 3. So 4 minus 12, which is what? Negative 8 over 3. Square it. That's 64 over 9. The y value. And this will be also 64 over 9. You can figure what that number is. And now let's look at the second derivative. Take a test value for the second derivative, less than negative 1.15. How about a negative 2? Between negative 1.15 and 1.15, how about a 0? Between 1.15 infinity, how about a 2 there? So the second derivative, now we're going to test the second derivative in each one. So what is the second derivative at negative 2? Again, all I care about, positive or negative. 4 times 12 is 48, minus 16, positive or negative? Positive. That's concave upward. What's the second derivative of 0? That's 0 minus 16, negative. That's concave downward. And what is the second derivative at 2? 48 minus 16, positive. That's concave which way? Upward. And I'm done. I can tell you this is an inflection point because it changes concavity. It goes from opening up to opening down. This is also an inflection point. And once I have that table complete, I can graph it. I can graph it right now and tell you what the graph looks like. So I can tell you where the function is concave upward, where the function is concave downward, where the inflection points. But I want to graph it. I'm going to add to that list. Here's what I know. Negative 2 and 0. 0 and 16. This is a min point. So I just go like this, min point. 0 and 16, somewhere there's a max point. 2 and 0, there's a min point. And I can go and find the value here for this. 64 over 9 is what? 6 maybe? 7? So somewhere here is an inflection point. There's one right here. So let's see what's going on here. Take them segment by segment, just that little segment right there, before you get to the minus 2. The function is decreasing, concave which way? Upward, decreasing, concave upward. Like this. What happens between the two lines right here? Just between the two lines. Still concave which way? Upward. And what is it doing now? Increasing. Increasing concave upward. Once it passes that line before you get to this point, it's what's doing now? Increasing, but concave which way? Downward. It's going to look like this. What happens from this line to this line? Still concave downward, but now is what? Decreasing. It passes that line. Still decreasing, but it's concave which way? Upward. And now increasing concave upward.
I was wondering why you space it out according to the numbers before.
Yep. Now, if I did this to scale, my graph will look a little bit nicer. But the graph really looks like this. It has a change of concavity. Notice that's the change of concavity here. These are the min points. Those increasing, decreasing. But once you have that table there, you know everything about that function. You can graph it. One more example, and we're done. Maybe I can find one a little bit different. Let's take this one. F of x equals x to the fourth minus 4x to the third. And I'm going to go through the whole thing. The first derivative, second derivative, and graph it. So the first derivative, which is what? 4x to the third minus 12x squared. Let's set it equal to 0 and solve it to get the critical values. I can factor 4x squared out. What do we have left? X minus 3. Set each factor equal to 0 and solve it. X equals 3, x equals 0. So we get two critical values. I'm going to make my table here on, I always make my table on a separate sheet because I'm going to be adding stuff to it. So I like it to be on its own there. One layer for the first derivative, the other layer for the second derivative. So this is the first derivative. This is the second derivative. Let's see what we know. The first derivative, we have to cut it into two cuts. One at 0 and one at 3. Again, this end is negative infinity. That end is plus infinity. Let me find the y value while I'm at it. When x is 0, I go to the function. 0 to the 4th minus 4, 0 cubed. That's 0. When x is 3, 3 to the 4th, is that 81? 81 minus, at the 108, is it?
Right, a little bit, you're right.
Yes, it's 108.
108. So what is 81 minus 108? Oh, I gotta turn this one on.
Negative 27.
Negative 27, the y value. Thank you. So now I'm going to pick a test point in each one of these segments. There's my values, 0 and 3. I'm going to pick a test point and plug them into the derivative. This is my derivative. So before the 0, what are you going to use? Negative 1, okay. Between 0 and 3. 1, okay, 1 is good. Makes the math easy. More than 3. You can, or 10, because when you have power, the 10 is a perfect one. You can get the answers quicker. 1s, 0s, 10s are really good to plug them in and get the answer without a calculator. What is the first derivative at negative 1? Plug it right here. That's a negative 4. That's a negative 12. Positive or negative? Negative. Decreasing. Let's try the 1. That's a 4 minus 12. What is that? Uh-oh. See now? The pattern's broke. I was waiting for one to break the pattern. Decreasing.
Why does that make it a critical value though? Is it because it just slopes and
It could come down like this. It could come down like this. And it goes like continue. So notice it's decreasing before that point, still decreasing before that point. Which is going to be an inflection point, possibly, that point. We'll see if it is. Now let's pick a value. So this is not a min, because decreasing is still decreasing. It's not a min, it's not a max. Let's try the 10 here. That's 1,000 times 4 is 4,000. minus 1200. I know that's positive, right? And that's increasing, so we know that's a midpoint. So there is no max here. We do not have a max because it goes all the way to infinity. It's coming down from infinity, possibly like this. It's coming from way up there. My gut feeling probably is going to look like this. So you're not going to have a max as it keeps going that end. It keeps going on this end. But there's a min. You just found that. So that's what my feeling tells me. Now let's do the second. I'm done with the first derivative. There's nothing else to do. So I need to take the second derivative. I can probably fit it on this page. What's 4 times 3? 12x squared minus what? 24x. Again, take it and set it equal to 0. Take 12x out. What's left? X minus 2. So 12x is equal to 0. X minus 2 is equal to 0. X is 2. X is 0. Ah, that 0 goes all the way through. See that? Same point. So let's extend the 0. But we also have another one at 2, which is somewhere here. That's a 2. That's where the 2 is. And when x is 2, again, what's the y value? Plug it here. What is 2 to the 4? 16. 4 times 8 is 32. What's 16 minus 32? Is that negative 16? So that's the y value for it. And now let's take a test point in each one of these segments and test it into the second derivative. So less than a 0. You want to stick with minus 1 still? Between 0 and 2. 1. More than the 2. 10, okay. Let's plug them in. What is the second derivative at negative 1? That's 1 times 12 is 12. Plus 24, all I care, positive or negative? Positive. That's concave upward. Let's try the 1. 12 minus 24, that's a negative. Concave which way? Downward. And let's try the 10. $1,200 minus 240, right? That's positive. Concave upward. Inflection. Inflection. Right here and right here. Concave up, concave down. Concave down, concave up. That's our inflection point. Change of concavity. Finally, I'm going to graph it. I know there's a sheet of paper here, graph paper. So let me graph it. Here we go. Once I'm ready to graph, all I have to look at is this table. This has everything I need to know. Ooh. I better make sure I make my x-axis, y-axis high enough. Hopefully I have 27 squares here. Or maybe I'll go by 2 with them.
Go by 3s. Make it easy on yourself.
Let's see. 0, and 0. That's this point. I should have moved it to the right even. But the next point is what? 2 and negative 16. In the x direction, I'm going to go by 2. 1, 2, negative 6. In the y, I'll go 2, 4, 6, 8, 12, 14, 16. On 3 and negative 27, 16, 18, 20, 22, 24, 26. Wait. Negative 16, 18, 20, 22, 24, 27 is right here. So let's see what's going on here. Before I hit the 0, it's decreasing, it's concave upward. Between this value and this value, it's decreasing but concave which way now? Downward. Between this line and this line, it's still decreasing but it's concave which way? Upward. And after you pass this line, it's increasing concave upward. And that's what the graph looks like. Following all these, decreasing, decreasing, concave up, concave down, increasing, concave up, increasing, concave up. Okay, before you leave, I have you do that evaluation because they're going to come look for them on Thursday. We won't be here. So again, if you show up on Thursday, I'll give you permission to take my parking spot. I'll let you sit outside for a while. Nobody will be here. The class number. Yes, please. There's pencils.
You're not supposed to, right?
What?
You hand it out yourself.
Oh, the night school? No, actually, that's okay. Because they don't have any pickup. Let me just see the numbers on the back.
Anyone need a pencil?
Let me see, Matt and Nico, let me see what the number on the back is. It's Matt 131.
Everybody
I'm
need a
gonna have
pencil?
Nico put a yard of tape on it.
The one guy who has a job as an engineer kind of thing right now is not very nice having that class.
Here we go. Take one of these guys and pass them on, please. Just one sheet, takes a minute to do.
Thanks, Patch.
And I'll shut the place. Don't bring them to me, just put them in the envelope.
You're not allowed to see them, guys.
I'm just gonna just steam them when I go home.
Everybody give him a bad review.
Are you telling me you don't have X-ray vision? You can't just see right through the envelope?
Well, you know, sometimes it's difficult. I lost a sheet here.
The manila envelope, your one weakness.
Oh, I tell you, it was like pulling teeth out of it. Like, hey guys, I'm not gonna be here. You know that.
Given that I get out of work at 4:45, I have half an hour to go home, take a shower, and get here, I'll take it.
Oh, did they give you one? Did they give?
No.
Oh, it's still making its way? Can you guys, take one, pass it, please? I know some of you have been sitting here for a long time. You want to get out of this place. Go on, get me out of this hellhole, huh? Okay, let's see. I will have the notes posted. I will see you, after you finish with this, I will see you on Monday. Unless I get somehow taken, asked for ransom there, so if they do that, don't pay it, because I want to stay there. I like the ones who want to leave, they just go, brrr, done. So you're gonna have two sections of homework open. And to make sure I don't forget opening them, because just in case I don't have internet access there, who knows, I'm gonna open them now. So you'll have no reason not to do the homework.
The homework is due Wednesday and Thursday.
It will be due,
Are you not gonna go over it?
well, you'll have a day, yeah, you'll have a day to ask questions on Monday. So probably due on Tuesday, after I come back. So you'll have Monday to ask questions.
So the section 3.4 and
Three.
3.3, just 3 point, I mean 4.3.
4.3 and 4.4.
Okay, because there's one and another one is due Saturday also.
That's probably the old ones.
No, 4.5.
Oh, those
due
are, yeah,
this Saturday.
this is based on the plan before my son decided to surprise me, and those would be moved actually. No, it's only 4.3 and 4.4,
So 4.3, 4.4 due next Tuesday.
Tuesday, yep. 4.3, what the hell is 4.3? Assignment. 4.3, I hate this software. I might be blind, I don't even see it.
See, by the way, I had an issue with the website. I called them. They said your professor can reopen stuff that the student did.
Safe trip, Professor.
Oh, thank you. Wait. Edit schedule, okay, let's see the schedule here.
I have one question.
4.3, here we go. Okay. Control minus, let me see it. Where's control minus? If everyone's done, take it, lots of tape and just wrap around this. Is everyone done? Oh, one more. To make sure it's fair. Let's see. Wrap it there. You still? One more. We're gonna tape the bottom, tape the top, make sure nothing escapes. Go ahead, put it in. There we go. Oh, come on, wait. Good. Yeah. Okay. Shut up. Get up there. More tape, please. There we go. More tape. I think we need more tape.
Why you got a table?
Just to make sure everyone feels good, like they were sealed and delivered to them. Now it's sealed. Can't say it was open. I can't see anything through it. They will get it that way. Edit schedule. The homework is due. No, not this week, so it's gonna be moved to the next week, okay. Cancel. What week are we? 8th, that's 8th, will be the 9th week. Reschedule to week 9. Will be Tuesday the 28th. Schedule. And which one is that? That was 4.3. Did I do the wrong one?
Yeah, you did.
4.2, I think.
Yeah, you did 4.2.
Reschedule to week 8, and that was scheduled to be done
By Wednesday.
for 4.3.
4.3.
Reschedule to week 9, and 4.4 4. Reschedule to week 9. Actually, I should have made 4.3. I'll change them. I'll make 4.3 due Tuesday because edit schedule. We'll make that due Tuesday so people don't wait to do them both in one night.
Are we, you should let them do it. You don't let them screw themselves, let them do it, see.
4.1. So this one will be pushed, reschedule to week 9, and that will be due. We meet on Thursday, Saturday, then
Wait, so we're still, we have to do the rest
So
of
if
it?
that's due August 1st, then you
7.
haven't 4.6 and 7. The class ends at August 6th.
they'll be moved too, but for now, I'm gonna move them. This is what, 4/7?
Shit, we're almost
Edit.
done.
So our final will be on August 6th?
Our final's the last day, yeah. Is it, what is it, August 6th? Is it August, whatever that day is? This just, I'm pushing the other ones best backward for now.
So final
Just
is
be in
funded
s-
only chapter
So it's
5
still,
or
what about
Final
section
for all.
5? What does that
I
do?
think it's all.
Section 5 is due on, now it's due on week 9, and section 6, which is actually, we did that today, which we'll be adding that quickly, edit schedule.
Chapter 5.
Chapter 5.
Yeah, you meant chapter 5, see.
Chapter 5.
Yeah, we're gonna do color sections from it.
We want to do it in like 3 because we don't, it's not even normally
Yeah.
covered in cap 1.
4,
Oh, yeah,
Like
5,
people from like,
4, 6, 4, 7, okay.
those two girls.
Well, chapter 5,
Last day.
will we have a chapter 5 test or
No.
will it be on the final?
That's calculus.
No.
Yeah.
That's just for people transferring the course somewhere
I was
else.
just
So we have
talking to
remaining
somebody
only two
outside, he said
exams,
they
right?
Huh?
take math too,
We
with
have
teachers
left 2 exams
teaching limits and
on
derivatives.
chapter 4
Take
and
math
final,
too.
right?
We have 4, yeah, 4th exam, we have final exam, correct.
Final contain all,
Everything.
yeah.
Even chapter 5 or not?
No,
No.
chapter 5, I cover one class actually, I cover stuff. If you're transferring somewhere else, you should know. Just in case they cover it, not every school covers it.
By the way,
We don't cover it here. Chapter 5, we cover that in Calc 2. But I want to make sure if somebody going somewhere else, that somewhere else might say, hey, you know what integration? And I don't know, someone said, no, I don't know what integration is. So,
but that's not in final though, part of the final, section 5.
nope. I might put a homework on it, but not a test.
Oh, cool.
Because otherwise, if I just say no homework, no test, nobody will listen. Yeah.
Well, I mean, everybody who's.
Z, I talked to Will Design, I had some issue, he said you'll be able to reopen them.
Only if
The
it-
assignments, and the assignments, if it was like.
Not if you
past-
missed a lot of them. Not if it's been a while. you
No,
missed a
I
lot of
haven't
them.
missed anything, I just for your information.
Oh, yeah, oh, I know that. You put a request, you have to put a request.
No, like, you know, if you try like a bunch of times, then you can't try anymore. You know, if you try,
Oh,
you have like 4
that I don't know
tries
how.
or whatever.
Yeah, that I don't know how.
It said you can reopen those,
I don't know
you
how.
know.
That I don't know how. Unless I change the number to 6, but I don't know how to reopen. That I don't know.
Yeah, if you just run out of your tries, you
Yeah.
know, whatever, they said you could reopen it, and if you don't know how to do it, you can.
I gotta call about something else. I gotta call him about the grade because the grade doesn't give me percentage. So I gotta do it myself. It's just 17 correct, 18 correct. Like, I don't want 17, I want, what is the score? Was that an 85, 83, 84? I gotta call.
No, it tells you the, well, it tells.
On the bottom, but when I look at your grade, it
Oh,
just says 17 out of 16, 15 out of 14. So I bring all the grades in,
And then you have to.
then I gotta do column by column, divide them by the number of values, which is stupid.
You want me to write you a program for that?
No, but I do in Excel, but I'm gonna talk to them about it. Any question about this one before I close it?
I have, but I have laptop with me.
So, okay, I can get out of this.
I'm out of here.
Good one.
Wait,